All right, here's the lesson for 10.4 hyperbolas part 1. All right, so hyperbolas are kind of like the inside-out version of an ellipse, right? It's made up of two parabolic curves, okay? And you still have a center, you still have vertices, and you still have foci, okay? Now, just like a parabola, okay, the focus is going to be inside of the parabola, right? And so that's why, well, we'll get to that in a little bit, all right? And so the equation here, where I'm circling, this is the standard form of a hyperbola, okay? Now, I try to color code this here. I wrote a squared in red, because I put red dots for the vertices. Okay, so A is still the distance from the center to the vertex, okay, or a vertex. And C is still the distance from the center to a focus, okay. So for the ellipse, we called it the major axis, right? And so the major axis for hyperbolas, we call it the transverse axis. And the minor axis we actually call the conjugate axis, okay? Now the conjugate axis, normally we don't plot these points, right? But it's actually going to be helpful in a little bit, all right? And I'm not going to try to explain everything right now. Some of this stuff I'm going to help you with in the examples, all right? And so the A value is still the distance from the center to the vertex. All right, this is A, okay. B value is up here, right? So this is B, all right. Okay, now so a couple things to note about the equation of a hyperbola. Just like an ellipse, always equals 1, all right? We're going to have fractions, and it's always going to be minus. Okay, now here's the thing. The first denominator is always going to be a squared. The second one will always be b squared. Okay, it does not matter which one is larger in this case. All right, remember when we did ellipse, the larger value a went under the variable according to the orientation of the ellipse. Okay. Now, what matters here is if the first numerator is x, then the parabolas are going to open up left and right. Okay, the parabolas are going to open left and right. Okay, the a value can be less than b, and that's fine for hyperbolas. All right. And so each of these parabolas, right, and I'm going to show you in one of the examples later, but these are bound by asymptotes. Okay, so this is a terrible asymptote, by the way. All right. Okay, and so the slopes of these are going to be plus or minus. All right. And so right now I'm just gonna write it down for now. Okay. So the equation of the asymptotes are going to be plus or minus b over a. All right, and I think this will make much more sense when we go through an example here, okay? All right, so this is the equation, all right, when the parabolas open left and right, okay? Now, when we go down here, all right, what I'm going to do is I'm going to take this, whoops, all right, what I did was I just copied and pasted that same picture, all right? But what if your hyperbola now opens up down? Okay, so now the transverse axis is vertical and the conjugate axis is horizontal. Okay, now how that's going to change the equation, right? It's actually going to look very similar. Okay. It's going to be minus, right, equals 1. And I said the first denominator is always a squared. All right, second denominator is always b squared. But because these parabolas open up and down, now the first numerator is going to be y. All right, y minus k squared. And this is going to be x minus h. Okay. So if you need to pause that or rewind and listen to that again, please do that. Okay. So those are the main differences from the ellipse. All right. One last thing here: the asymptotes for when it's vertical, all right, are going to be y equals plus or minus a over b. All right. And again, I think it'll make more sense when we start going over these. All right. So here we go with example number 1. All right. I drew in a set of axes here if you want to do that in your notes. All right. I know that this has to equal 1. All right. So I'm going to divide everything by 225. All right. Because the right hand side needs to equal 1. Okay. 9 over 225. Right. This actually simplifies to x squared over 25. And then this is going to be y squared over 9, and that's going to equal 1. All right. Now, since this is just x squared and y squared, the center is going to be at 0, 0. All right. Okay. So which I wrote here, center's at 0, 0. All right. Remember, the first denominator is always a. Okay. Or a squared. So a here is going to be 5. And C is going to be, I'm sorry, not C. B is going to be 3. Okay. Now, what that means is, since the first numerator is x, right, the parabolas are going to open left and right. Okay. That means that the vertices are going to be 5 left and 5 right from the center. Okay, so let's say this is -5 and this here is +5. All right, these are your vertices. Okay, now I'm not just gonna draw and guess like what the parabolas are going to look like. Okay, and here's what we're gonna do. The b, this is where the b comes in handy and helpful. All right, so the b value is 3, so I'm going to go up 3, right? And I'm going to go down 3. All right. Remember, this is called the conjugate axis. All right. And so what you create between these 4 values, right? It creates this invisible box. Okay. There we go. All right. Okay, because what the box does is if you connect the diagonals, right? So I'm gonna draw, or I'm gonna do it in purple here. All right. As maybe some of you guys are predicting, the diagonals are the asymptotes. All right. That's why we need that b value. Okay. So I'm gonna draw this here, like that. Right, and we're going to extend this, right? And so now the curves, right, from the vertex here, right, you're just going to draw it with the guidance of the asymptotes. All right, like that. And there we go. Okay, that's our hyperbola. All right. I suggest that you do draw in these rectangles to, help you draw the asymptotes in. All right. Now, you are going to be asked, what are the equations of those asymptotes, right? And I'm going to write that here. Okay, so we know it's going to be y equals, because it's the equation of a line, all right? And so from the center you pick one of the corners of this rectangle, right? I always just like to go to the right, up and to the right, okay? Well, what's the slope from the center to that corner? Well, that's going to be up 3, along the conjugate axis, right? And then to the right 5 along the transverse axis, right? So that's why, you know, the general form is plus or minus b over a in this case, all right? Because we're going up b and then to the right a. So here the equation is going to be y equals plus or minus 3/5, right? And it's negative 2 because we have this other one right here. Okay. For the foci, all right, maybe we'll do that in blue also. This is all over the place, I apologize. Now the difference for the foci for hyperbolas is c squared is equal to a squared plus b squared. Remember for ellipse, it's a squared minus b squared, but it also kind of makes sense that it's a squared plus b squared because the foci, the value of c, now has to be larger than a, right? Because remember, a is the distance from the center to a vertex. And so if the focus is inside the parabola, right, this distance has to be longer than the distance to the vertex, all right? Okay, so for this one, c squared is going to be equal to, when I add 25 and 9, that's going to be 34. So c is going to equal the square root of 34. All right, so the coordinates are going to be plus or minus square root of 34, comma 0 in this case. Okay. Now, like I said, you know, as I've been saying, right, you go to your calculator to figure out what is the square root of 34, right, so that you can count when you sketch it, all right? Okay. All right, so for this example, I started with a sketch, all right, given the information, okay? This one, because of where the foci are, you can tell that the center is going to be at 0, 0. Okay. Now, since the foci are at -5 and +5, right, that means the c value is going to be 5, right, from the center out to one of the focus points. It's going to be 5, all right? I also know that because the foci are horizontal, okay, that means the first numerator is going to be x squared, right? Remember, whatever the first numerator is, that's the direction the hyperbola opens, okay? I've got a vertex of 3, all right? So that's the a value, okay? All right? Remember, the a value is always the distance from the center to a vertex, okay? And I also said that the first denominator is always a squared, so this is going to be 9, all right? And obviously, if the first numerator is x squared, then the other numerator is going to be y squared, okay? Now we got to figure out the b squared, okay? So I'm going to use c squared is equal to a squared plus b squared, right? We know that c is 5, so this is going to be 25. And a is 3, so this is going to be 9. 9 plus b squared. All right. And after a little bit of work, all right, b squared is 16. All right. Which means b is 4. Okay. So 16 goes here. All right. Now that's the equation of the hyperbola. Okay. Now the 4 comes in handy because, again, that's where the asymptotes are going to be, right? So I'm going to go up 4 and down 4, okay? And this was at 3, right? Or -3 in this case. And so I need to create this box, right? The rectangle to draw the asymptotes in, okay? All right, so the equation of the asymptotes, sorry for my messy handwriting, is going to be y equals plus or minus 4/3.